Hi guys, now you are going to learn about the phase conversion by transformers. In general, industrial applications, we have electric furnace and induction furnace, and we have welding and all those things. So for these kind of applications, we need a balanced two-phase supply. But we are generating a three-phase supply. Okay, we are generating a balanced three-phase supply. So what do you mean by balanced three-phase supply? See, in balanced three-phase supply, each phase is displaced by 120 degrees. If you consider this is R phase, Y and B, so each phase is displaced by 120 degrees, then we can say the supply is a balanced three-phase supply. Okay, so for phase difference, we have phase difference. We have a formula that is 2 pi by m. Okay, find the phase difference. This formula is valid for greater than two phases. Even it is not equal to two phases, greater than two phases. So where m represents number of phases, like 3 phases, 4 phases, 6 phases, like that. Okay, so this formula is not valid for two phase, and even it is not valid for single phase supply also. Okay, so why it is not valid? See, for two phase supply, m is equal to 2. Am I correct or not? So if you apply the same thing to this formula, what is 2 pi? 2 pi is equal to 360. 360 by 2 is equal to 180 degrees. 180 degrees in the sense, it is a phase difference between two phases. See, if you consider VA is the one phase voltage and VB is the other phase voltage. According to this formula, what is the phase displacement? That is 180 degrees. 180 degrees. What the thing happening here is, here the magnitudes of voltages is the same. Magnitudes of voltages is the same, but they are in opposite direction. They are in opposite direction. Means the resultant voltage will be 0. So they are in equal magnitude, but they are in opposite direction, means resultant voltage is 0. So this formula is not valid for two-phase supply. This formula is not valid for two-phase supply. So now what are the requirements for two-phase supply? See, the requirements for the two-phase supply are, first requirement is the voltage phase must be 90 degrees to each other. So voltage phase must be 90 degrees to each other, in the sense the phase displacement between VA and VB must be 90 degrees. See, this is VA and VB must be like this, and phase displacement between VA and VB should be 90 degrees. That is the first requirement. And second requirement is the magnitude of voltages. See, VA is one voltage and VB is another voltage. The magnitudes of voltages must be same. Magnitudes must be same. Okay, so these two are the conditions that are to be satisfied to become a balanced two-phase supply. To become a balanced two-phase supply. So in general, get these two requirements, that is the phase displacement between V and VB is 90 degrees and their magnitudes must be equal. So to attain these two things, we require two single phase transformers. Two single phase transformers. Okay, so by using two single phase transformers, we can convert a balanced three phase supply to a balanced two phase supply. See, by using two single phase transformers and connecting them with a special name, that is a Scott connection. Scott connection is a different kind of connection. Okay, so if you connect only in this way, is if you make a Scott connection between two single phase transformers, then only we can get these two conditions, means then only we can get a balanced two phase supply. Okay, now what we have to learn? We have to learn what is a Scott connection, how we have to connect these two single phase transformers. That can be learned in the immediate video. Thank you.